Hi, I'm Patrick Mann from PHY International, and I'm very excited to be here at the octoScope facility in Littleton, Massachusetts, and I'm joined by CTO Lee Chinitz. I'm here to talk about Triathlon, a very important advance in wireless test. Lee, tell us all about it.
Triathlon is what we call a multi-layer cross-probing analysis tool. That's a lot of words, and what we mean by that is that Triathlon allows wireless developers to be able to view the same information from multiple different angles. More specifically, when we're talking about Wi-Fi, we're talking about being able to analyze information at both the RF and the MAC and PHY layers sort of simultaneously. The reason for this is that typically in wireless development, right, it can be very complicated, and it's especially complicated when the technology is new. We're facing that situation right now, for example, in Wi-Fi, as Wi-Fi 6 is being developed and is really just coming to market. So in the early phases of technology development, we have a lot of pieces that are, again, just being developed. So, for example, we have hardware and software that is very new. We have firmware and drivers, application-level software that is really just being tested and is not very stable. The RF environment can be very dynamic, and implementation of standards can mean that interoperability can be very difficult to achieve. So when developers are looking to try and understand a problem, for example, maybe they're looking at some of their newer products and they sense a low throughput problem. They'd like to understand where that comes from. That can come from a lot of different places. So for example, that could be an RF problem, say for example poor EVM in the signals actually being transmitted. It could be a PHY level problem. For example, the data rate selection algorithm may be poor, it may be selecting poor data rates. Right. It could be a MAC level problem. Maybe packets aren't being aggregated together, and that can lead to low throughput. So these are all ways that low throughput could manifest itself, and the question is, how would developers be able to figure out what is the actual cause?
So how do you track it in real time between the protocol layer and the RF output, right?
Right.
Yeah.
So what do people do now? Now you tend to have different teams using different tools trying to understand the same data. So you may have a team that's focused on the protocol layers, the PHY and the MAC, using a classic protocol sniffer, capturing data in PCAP format and then analyzing it using a protocol analyzing tool like Wireshark. At the same time, you may have a team that's really focused more on the RF, using an RF sniffer, wanting to look at information like the constellation, for example. And the question is, how can those two teams effectively and efficiently work together? Currently, it's very difficult. Even if you can reconstruct packets from the RF information, which you can, it can be very difficult to know which packet in the RF capture is the same as the packet in the protocol capture. And even if you can figure that out, it takes a long time. A lot of work done just by hand or by eye, trying to line up captures. The other difficult part, of course, is making sure that you actually capture the data in the RF sniffer that you want to capture. That can be very difficult to do, and that's often also a manual process of trying to generate a problem and then manually trigger the RF sniffer to capture information at the time that the problem is occurring. How does Triathlon help that situation? Triathlon is a combination of both hardware and software. From a hardware point of view, of course, it includes both a protocol sniffer and an RF sniffer, allowing those two devices to work in tandem. But more importantly, Triathlon is made up of software elements that do several important things. So first of all, one of the software elements actually acts to merge together the information that was captured by the protocol sniffer and by the RF sniffer. And so what we were seeing here is actually the combined set of data that was gathered by both of those. Triathlon also lets you click on any individual packet and immediately see the RF information related to that packet.
Did you require any hardware changes to make this happen with the software, right? I mean, clearly it's a software innovation in many ways, but were there any requirements on hardware?
Yeah, and you've touched on the other main software component of Triathlon, which is what we call event-based triggering. What event-based triggering means is that we allow the user to actually create trigger conditions so that we can have the RF analyzer or the RF sniffer, capture only the packets that are of interest. The way we do that is we have the protocol analyzer analyzing the packets in real time at line speed, and when the conditions that have been set by that trigger are actually reached, a trigger signal will be sent from the protocol analyzer to the RF analyzer, and it will cause the RF sniffer to capture and store packets. Right. And so that's what we're showing here. We call that event-based triggering, and that's the other main component.
It's kind of important too, especially from the RF analyzer point of view, because there's only so much memory available.
That's exactly right. And that's really primarily the reason for it. It's really not possible to capture packets at the RF level for a very long period of time because they are IQ samples. It takes a lot of space to store that. And what had happened previously usually was really more of a hit and miss process where people would try and capture the packets that they needed using the RF analyzer or RF sniffer by looking for the event and then triggering that device manually. Right. What we've allowed them to do is actually trigger it based on predefined trigger conditions.
Can you track it before it actually happens then too? Can you set
yes, so
pre-trigger?
Exactly, yeah. The trigger itself will fire whenever the conditions are met, but the packets that are stored by the RF sniffer are programmable. That is, you can capture packets that came before the trigger, that came after the trigger, that come around the trigger. That's completely configurable. Okay, so what this looks like in terms of a flow chart is shown on this slide. We have packets coming into the protocol analyzer, and what's shown on the bottom here is the normal path through the protocol analyzer, where those packets are then just captured as PCAP format. We also break them out, and right at the driver level, we actually do some sort of pre-analysis, and then we run those packets through our programmable trigger logic. And again, that's why it happens so quickly, and we're able to do that at line speed.
So you or the user can actually set up those triggers themselves, right? Program them in, right?
That's correct. It's completely programmable by the user. So at a very high level, if we want to put triathlon together completely, it looks something like this. And triathlon itself is made up of all the things that are shown here in green. Mm-hmm. We have the ability for the user to set trigger conditions and program those into the protocol sniffer. When the protocol sniffer then begins to capture packets, it is able to throw a trigger signal out to the RF sniffer. And then we have two simultaneous captures, one at the protocol layer, one at the RF layer. We then have software that will merge those two together, that will create a merged capture file. Mm-hmm. And then finally, we have the ability to click on those packets in that file and have one-click visibility through right down into the RF level.
So this zebra pattern shows that the two signals are in lockstep at this point, right?
That's right. What you're seeing here are packets that were captured by the protocol analyzer and packets that were captured by the RF analyzer, and they're intermixed in here. In fact, you're going to see more of that when you see a live demo of the triathlon system. You're going to have an opportunity right now to head on over to the lab where you're going to meet one of the inventors of triathlon and our lead triathlon developer, Andrew McGarry, who's going to take you through a demo.
So Andrew, what do you have here?
So this is an example of one of our triathlon systems. So for the RF analyzer, we've partnered up with LightPoint, and specifically, we have here a LightPoint IQXL M16W. So the LightPoint is going to provide the RF analysis, and it has a configurable window so that we can set it to capture events that happen before the trigger, after the trigger, right, or exactly right around the middle of the trigger event. Yeah, so this is the LightPoint for our RF analyzer. And we also have a PAL6 module stored down here in the bottom of the Octobox 26 chamber. So this is going to be our protocol analyzer. The PAL6 also comes in a standalone version, like we have right here.
Right.
Yeah. So the PAL6 is a Wi-Fi chipset-based Wi-Fi analysis device, and so it's capable of 8x8 MIMO. Fully supportive of Wi-Fi 6, so it also does OFDMA. It also contains a 2.4 gigahertz radio right here.
Oh, okay.
Yeah. And so for triathlon's purposes, it also has a trigger out.
Ah, see right here, okay. Yeah, very nice, okay.
Yeah.
So the output, so in the box, and the output of the trigger is sent around to the RF sniffer, the light point system. Okay.
Yep. So that's how we correlate the measurements between the RF analyzer and the PAL6.
So that's actually very unique then, so having the trigger coming out from the PAL to trigger the light point is really one of the unique aspects, I guess, of what is triathlon, right?
That's
Being
right.
able to trigger on an event, right?
That's right. That's how we make sure that the results match up at the end.
Right. So it's all time correlated as such, right?
Right.
Okay.
Yep. So in terms of other equipment that we have in this system, we also have an access point inside the chamber, as well as an example station. So these two devices are associated with one another, and so we'll be sending traffic between them. So that'll be the traffic that we analyze.
Okay, so let's do the demo. Let's go through it.
Yeah, so the first thing that we do is we set up the event-based trigger. All right, so I've already configured this so that as soon as the PAL detects its 5th CTS frame, it'll send out the trigger pulse.
Okay.
Yeah. The next thing that we do is we set up the light point analyzer. We want to make sure that the window of capture is centered on the trigger event. Yeah. At that point, we're ready to go.
Okay, let's do it. Okay.
The analysis is currently getting set up. We're pushing settings to the PAL6 as well as the light point analyzer. In just a minute here, the PAL6 will start capturing as it is right now.
Okay.
Right, the event was captured.
So it's captured the CTS, and now it's analyzing data coming in.
What it's doing is it's pulling the PCAP capture from the PAL as well as the light point.
Okay.
Yeah, and
Gotcha.
it's crunching them. Yeah.
Oh, I think something happened.
So at this point, the light point RF capture as well as the PAL6 protocol sniffer capture have been merged together. So the results of that merge are presented in this file here. So if I scroll down, we'll come to a portion where here we are. We have light point packets interleaved with PAL packets.
Right. And they've triggered on the CTS signal.
That's right.
Okay.
Yep.
And you got a portion before the trigger and after trigger, right?
Right. We can configure how much time is before the trigger event as well as how much time is after the trigger event.
And time correlated. Okay, so now we can see it both in sync. Okay.
Right.
Can you give a quick demo of what the light point signal and the protocol analyzer are showing right now?
Sure. Yeah. So the packets in gray here are packets that are captured by the PAL.
Right.
The ones in blue are the ones that were captured by the light point. So to look at the protocol side of information, what I can do is I can highlight one of the PAL packets and then use the Wireshark user interface to take a look at that information.
Right.
Yeah. So as soon as I want to take a look at the RF information for a particular packet, then what I can do is click on one of the blue packets, any one of the light point packets. So this one, for example, is a data packet, right? So we'll watch this screen. As soon as I click on this, the results, the RF results for that particular packet are now shown.
Up and time correlated to the actual protocol itself. Okay. That's very nice. Okay.
Yeah.
Can you look at different packets then at this point, right? You can look at control packets, what have you.
Yeah, control packets,
whatever.
management packets, anything that's blue and shown in this capture, yeah, can
see right
be
here,
can be
okay.
shown in the light points user interface. Yeah.
So that's the beauty of it, right? It just brings it all together in one screen.
Yeah, exactly. Yeah, exactly. What makes triathlon special is that we show protocol information simultaneously with the RF information for particular packets.
Or an event that's happened and you're tracking it in real time almost, right? Okay. Whereas before you would have had to look at the protocol analyzer and the RF analyzer and hopefully at some point find something that's correlating to what you might see in one versus the other, right?
Right. Yeah, that would have been a process of elimination, just by looking at these two separate things and trying to match them.
Which would take you typically how long, roughly?
Goodness. That could take minutes, whereas it happens instantaneously when you click on them.
Very nice.
Here.
Okay.
Yeah.
Good job. Okay, thanks for the demo. Very nice. Well done. Thanks, Andrew.
Thank you.
Ellie, I saw the demo and it was really good. How did it come about?
Triathlon was actually created really on the request of our customers, especially some of the larger chipset vendors who were really working on some of the newest wireless technology. So for example, Wi-Fi 6, which is only now really coming to market. Wi-Fi 6 has a lot of interesting and difficult requirements that are new to Wi-Fi, specifically because it has OFDMA as part of the protocol. So OFDMA requires some very tight requirements in terms of timing, power, and frequency synchronization. And there's really no way to test those kinds of operations with the existing kind of protocol level analysis. You really need the sort of synchronized analysis with the RF layer that we've been able to do with triathlon. And so that's where it really came from. And right now we're seeing a lot of interest in it from exactly that part of the market, the large chipset vendors. But now that it's available, we've also seen a lot of interest even from the equipment vendors and even operators who are, just beginning to deploy this new Wi-Fi technology.
What's the next stage for you for development?
Our latest PAL, the PAL 6 that we've already talked about, also incorporates Bluetooth functionality, and we're extending Triathlon to incorporate Bluetooth operation as well. In addition to that, as people get more experience using Triathlon, we're continuing to build up our library of event-based triggers so that people can start with our library as well as creating their own personal triggers that they want to look at.
Nice job. Okay, thanks, Lee, for your time. Really appreciate it.
Thank you.
And this is Patrick Mannion from Wire International signing off from octoScope facility in Littleton, Massachusetts, where once again they've shown that they're one step ahead when it comes to wireless tests.
Premium